Number 7, let f of x be a polynomial function and define the function g of x as 5x squared plus x times the f of x. And given that f of 3 equals 2 and f prime of 3 equals 1, what is the value of g prime of 3? So for this problem, they're asking for the value of g prime of 3. In other words, the derivative of g of x evaluated at x equals 3. That means, obviously, we will need to differentiate both sides of the equation they gave us. Yeah, that's pretty much the first step. And let's go ahead and take the derivative of both sides. So first step. So it's totally fine to differentiate both sides of this equation. That's because it's an identity. And as long as both sides are differentiable, we are good with that. And in this case, they are g of x, f of x, and x, 5x squared. Those kind of things, they are all differentiable functions. So yeah, we can go ahead and do that straight right away. So first, let's start with the left-hand side. If we differentiate g of x, we get g prime of x. Now for the right-hand side, we have 5x squared plus x times f of x. Let's take it step by step. So first term is to differentiate this, right? So 5x squared. Now, guys, do you remember how to differentiate x to the n? First, you bring the exponent down in front, so it becomes n times x, right? And then you guys subtract 1 from the exponent, which becomes n negative 1. So in our case, it's 5x squared, right? So 5 times, let's differentiate x squared. First, bring exponent down to the coefficient. And x, part of 2, it was originally 2, but put that down by 1, so it becomes 2x part of 1. Now 5 times 2 is 10, so it's 10 multiplied by x part of 1. Plus, now the second term. For the second term, x times by f of x, this is a product of two functions. So we were going to use the product rule. So let's go on quick review on that. Let's say there is ux times v of x. When you differentiate this, it's u prime of x times v of x plus u of x times by v prime of x. And yeah, this kind of feels really fair, right? You take turns differentiating each part while keeping the other part the same. And then you just add them together. So that's how the product rule works. So it's like differentiate one part, leave the one part alone. This is the first term. Then switch it. Don't differentiate the first one, but this time differentiate the second one instead. That's the main idea how this works, I guess. And this same rule actually extends to the products of 3 or 4 functions or even more. You just keep going one at a time. Differentiate one and leave the rest as they are, and add up all those terms like that. Alright, so now let's apply the product rule to the specific problem, which was x times the f of x. For here, u of x is just x, and v of x is f of x. So we'll use the exact same rule to this. First, we differentiate the first part, that's x, and leave the second part as same, f of x. And it is the derivative of x is 1, so we get 1 multiplied by f of x. Then, like we said before, it's fair. Now we leave x as it is, and we differentiate the second part, which is f of x. That gives us f prime of x. Therefore, the derivative of this is this. Now the second step. The problem is asking us to find g prime of 3. It totally makes sense to just plug in x equals 3 into this equation we just found for g prime of x. That's the next obvious step to go. Alright, let's go ahead and substitute 3 into both sides. G prime of 3 equals 10 times 3 power of 1 plus 1 times f of 3 plus 3 times f prime of 3. Now, the problem gives us the exact values. They told us that f of 3 equals 2 and f prime of 3 equals 1. So yeah, we can just plug those in right away. Replace f of 3 with 2, f prime of 3 with 1. 10 times 3 is 30. 1 times 2 is 2. 3 times 1 is 3. 30 plus 2 is 32. 32 plus 3 is finally 35. Now this is our final answer. Number 5 is going to be our choice.